Igniting curiosity across depots, command centers, and beyond. Welcome to your weekly Depot AI Brief, where emerging AI meets mission-ready insights. This is episode 14, Empowering Soldiers with AI Tools. Today, we're breaking down exactly how these AI updates impact our four core roles, from the shop floor to the executive suite, and we'll wrap up with key highlights and insights on the commercial tools flashing on our industry radar.
Yeah, and it's really is a massive shift we're tracking right now. We're sort of moving away from treating artificial intelligence as this futuristic concept and actually looking at how it fundamentally changes the daily mission for, every single person in the formation.
Right, because if you're out there managing a depot right now or just turning wrenches, you might honestly be rolling your eyes at the phrase AI modernization.
Oh, absolutely.
You might be thinking, look, I'm still dealing with broken legacy software and physical clipboards, so how is an algorithm going to help me? And that is exactly why we want to start right where the physical mission happens. So picture the floor at facilities like CCAD, the Corpus Christi Army Depot. You have artisans, mechanics, logisticians, all moving parts and just keeping Army aviation in the sky. But for decades, that artisan has been completely bogged down by manual tracking.
Right, and we're seeing a direct transition of that supply chain power straight into the hands of the soldiers to solve that exact frustration. A perfect example from our sources is the Paraline mobile app.
Okay.
Historically, conducting inventory at the company level was just a grueling process. It could take weeks of manual counting and clipboard tallies. But now, with Paraline, artisans are using mobile devices to simply scan IUIDs, item unique identification tags.
Which, for anyone unfamiliar, is essentially a highly durable barcode, right? Like a matrix that acts like a fingerprint for a specific piece of equipment.
Exactly. It ties that physical item directly to the central database. So by scanning those tags, an inventory process that used to take weeks is now being completed in literally days.
Wow. Just giving that time back for actual maintenance work is a massive win.
Yeah.
But the tools are going beyond just counting parts, right? There's an upcoming app mentioned in our stack called Checkmate, and it uses AI-assisted guidance for PMCS, which is preventative maintenance checks and services. Basically, the routine inspections you do to keep gear operational. And Checkmate actually helps them troubleshoot faults and order replacement parts directly from the field.
Yeah, and the mechanism that makes Checkmate so powerful is the data integration. Yeah. Both Paraline and Checkmate connect directly to authorized live data inside GCSS Army.
The Global Combat Support System, Army.
Right, the massive digital backbone for Army logistics. It's bringing the power of that enterprise system right down to the tactical edge, and it's doing so within an IL-5 environment.
An IL-5, Impact Level 5, that's a highly secure network designed specifically for sensitive, mission-critical military data.
Precisely. You aren't just trusting a random commercial app. You're operating securely.
But wait, it's not just digital data moving to the tactical edge, is it? We're actually seeing physical manufacturing move there too.
We are.
Because the sources highlight how 3D printing or, advanced manufacturing is totally overhauling the supply chain. Army Material Command recently qualified 61 parts for use in just 57 days using new authorities. And their next goal is qualifying 425 parts in 12 months.
Yeah.
How are they moving that fast without compromising safety?
Well, they're achieving that speed by utilizing what we call digital twins.
Okay, what's that?
A digital twin is a virtual, highly detailed replica of a physical part. So instead of manufacturing a physical prototype, shipping it, putting it in a machine, and literally breaking it to test its limits, engineers use the digital twin to simulate heat, vibration, and stress virtually.
Oh.
Right, so by the time they actually 3D print the real part, they already know exactly how it's going to perform. And the ultimate vision here is having standardized 3D printers at the tactical level, allowing soldiers to manufacture temporary replacement parts right at the point of need.
That just blows my mind. But if we're printing parts locally, how do we guarantee they're flawless? This brings up the predictive maintenance and AI vision data from our deep dive. The research shows that human inspectors, simply due to natural eye fatigue at the end of a long shift, miss about 20 to 30% of microscopic defects.
Yeah, it's just human nature. But AI vision systems, they hit 95 to 99% accuracy.
Wow.
Because an AI vision system doesn't get tired. It uses a camera mounted over a workstation to take high frame rate images of a part, and it compares the pixel variance against thousands of baseline images of perfect parts. It can spot a microfracture that is entirely invisible to the human eye, inspecting upwards of 10,000 parts an hour.
That's incredible.
And furthermore, Predictive AI algorithms analyze historical maintenance logs and sensor data to foresee an equipment failure 30 to 90 days in advance.
It's like having a check engine light that actually speaks English and tells you your water pump will fail in exactly 2 months, rather than just glowing ominously on the highway.
That is an excellent analogy.
Yeah.
And when applied to depot maintenance operations on motors or gearboxes, this predictive capability reduces unplanned downtime by up to 50%. And it extends the lifespan of the equipment by 20 to 40%.
That's huge.
It is. But we have to remember the Department of Defense rules at play here. When deploying AI in defense environments, a human in the loop is mandatory.
Right.
The AI vision system isn't replacing the artisan. It's an over-the-shoulder assistant. It prioritizes explainability, meaning the AI must highlight exactly why it flagged a part so the mechanic makes the final call.
Okay, so the mechanics are generating all this incredibly rich data on the floor. Where does it go? Well, it goes to the analysts. These are the folks who have to actually make sense of all these digital twin simulations and predictive maintenance logs.
And this is where we run into a really fascinating reality check for the data crunchers. According to a recent EY survey of federal leaders, the biggest barrier to AI modernization isn't actually getting access to the technology itself.
Right, I saw that in the notes. 44% of leaders cited the workforce skills gap as their top barrier, and 48% pointed to fragmented legacy data systems.
Yeah,
So the bottleneck isn't the AI, it's the fact that our data is trapped in silos.
precisely. You cannot just drop an LLM, a large language model, on top of fundamentally broken or siloed data and expect magic. An LLM works by predicting patterns in data.
Right.
So if the underlying data is scattered across 1990s mainframe databases and just disconnected spreadsheets, the AI either hallucinates false answers or gives you nothing at all. Most agencies find themselves stuck in the pilot phase because they just lack that foundational data architecture.
But the Army is trying to bridge that gap by effectively creating a new role, right? The soldier developer.
Yes.
And they're doing this using authorized tools inside that secure IL5 boundary we talked about earlier. Tools like GenAI.mil, Palantir Army Vantage, Ask Sage, and Microsoft Copilot. These platforms are giving analysts the power to build their own software and AI agents without needing a computer science degree.
It democratizes data analysis. With a tool like Ask Sage or Army Vantage, an analyst doesn't need to know how to write complex SQL code to query a database. They can just use natural language.
Really? Just normal English.
Yeah, they can type, "Show me all the supply chain bottlenecks for helicopter rotors in the last 30 days." And the authorized tool interacts with the data securely to produce that report. You're empowering the people closest to the problem to build their own solutions and replace those clunky multi-tab Excel workflows.
Okay, let me push back on this, though.
Sure.
If every single soldier becomes a software builder using GenAI.mil, don't we risk total chaos? A million custom apps with no central control. I mean, if that soldier transfers to a new base, their custom app just breaks and nobody knows how to fix it.
That is an incredibly valid concern, and it's exactly why AI governance is so critical right now. The survey notes that only 38% of federal agencies currently have a comprehensive AI governance strategy.
That's pretty low.
It is. The goal is managed innovation. You let the analysts build and experiment within those secure IL5 authorized platforms to see what works locally, but you govern the environment so that when a soldier builds something genuinely successful, it can be audited, documented, and then safely scaled across the entire enterprise.
Which is why we're seeing commercial partners step in to provide that auditing layer, right? Like IBM recently expanded its FedRAMP portfolio on AWS GovCloud to include their watsonx platform.
Exactly.
The watsonx governance tool provides the specific documentation required for AI accountability, so it ensures that as these soldier-developed tools scale, they remain compliant and traceable.
Right. So if we step back, we have artisans 3D printing tactical parts and analysts building custom query apps. The natural question is, who manages this ecosystem?
Right, the team leads. How does a supervisor manage a team of soldier developers on their laptops while also maintaining quality assurance on the floor?
It is a profound shift in leadership responsibilities. For one, the entire OIB, the organic industrial base, which encompasses all the manufacturing arsenals, maintenance depots, and ammunition plants, is undergoing continuous digital transformation.
Right.
The workforce is being upskilled through smart factories, virtual reality training, and digital micro-credentialing. The speed of change is unbelievable, and supervisors are the ones tasked with orchestrating it.
But put yourself in the shoes of a supervisor who maybe hasn't touched a line of code in their life. Suddenly you're told you have to manage digital twins and oversee AI vision inspection systems. That's incredibly daunting.
It is, which is why there's a highly practical initiative from the Department of Labor gaining major traction called Make America AI Ready. It's a free 7-day AI literacy course designed to be as accessible as possible.
I found the delivery mechanism of this course so fascinating. They deliver this cutting-edge AI literacy training entirely via SMS text message.
Yeah, it's brilliant.
You literally just text the word ready to 2022, and it sends you bite-sized lessons taking less than 10 minutes a day, using the oldest, most low-tech mobile tool available to teach things like how to talk to AI. I mean, it's a really smart way to cut through the noise and lower the barrier to entry.
It's designed specifically for workers and leaders who don't have a technical background, just bringing everyone up to a baseline understanding. And supervisors desperately need that baseline because their workflows are becoming highly technical. For example, when those artisans we talked about 3D print a new tactical part, the supervisor has to manage the complex workflow of sending that part's data to TACOM, the Tank Automotive and Armaments Command, or AMCOM, the Aviation and Missile Command, for official certification.
Because quality assurance isn't just a box to check. You can't just print a part on the front lines and hope it holds up under the stress of a combat environment.
Precisely.
Yeah.
And this ties directly back to implementing those AI vision inspection systems. Supervisors need to understand the financial and operational ROI, the return on investment of quality assurance. In manufacturing, there's a concept known as the rule of 10.
Okay, walk us through the math on that because the financial cascade here is just wild.
Yeah, so if a defect is caught right there at the inspection station, say, by our AI vision system, it might cost $1 to fix. It's an immediate, localized correction.
Makes sense.
But if that defect slips past the station and is caught by the customer during final assembly, that cost jumps exponentially to between $100 and $1,000 just because of the rework required. Right. But if that defective part makes it out to the field and causes an equipment failure that requires a recall or a grounded fleet, that cost scales to $10,000 or substantially more, not to mention the risk to the mission.
Right. So dedicating resources to train an AI model to catch the defect early isn't just a fun science experiment. It is a mission-critical financial imperative.
It is. However, supervisors need the technical literacy to know that an AI vision system doesn't just work out of the box. It requires between 500 and 2,000 labeled image samples per specific defect type to train the algorithm effectively.
Wow, that's a lot of data.
Yeah, so the supervisor has to allocate the man-hours to label those images up front before the system can save money later.
And allocating those man-hours requires budget and top cover, which brings us to the command suite, the executive. To give supervisors the resources to train these models and analysts the authorized platforms like GenAI.mil to build apps, executive leadership has to cut the red tape and set the strategy.
Exactly. Executive leadership entirely sets the tone for AI adoption. We saw this emphasized recently with Secretary of the Army Christine Wormuth's visit to the Army Cyber Command.
Right.
Her messaging underscored the Army's commitment to AI as the decisive global edge in future warfare.
One thing that stood out to me from her visit, and just the broader defense consensus, is how we frame this technology to the workforce. Executives are strictly defining AI as an empowerment tool. It augments the Army professional. It does not replace human judgment.
That's right. But to actually equip that Army professional with these tools, executives are fighting massive acquisition battles. We're entering what defense analysts call the algorithmic battlefield.
Sounds intense.
It is. This requires a completely new breed of acquisition leader who is trained in data science and rapid software iteration.
Because traditional procurement is designed for buying a tank hardware that drops on the lot and stays mostly the same for a decade. How on earth does that system handle buying an algorithm that learns and changes every single day?
It struggles immensely. The Pentagon's acquisition reform efforts are constantly colliding with budget inflexibilities. Congressional reports recently pushed back on the Army's request for agile funding, which is money specifically designed to be flexible enough for rapid software updates.
Right, because the Department of Defense budget system is structurally less flexible than civilian agencies, and that rigidity directly hinders rapid technology adoption.
Exactly. And furthermore, trade groups are currently sounding the alarm over the GSA's, the General Services Administration's, draft AI procurement guidance. Industry fears that heavy compliance burdens and overregulation will just slow down deployment even further.
So if executives are constantly fighting the budget structure and the procurement rules, how are they actually getting these AI tools across the finish line?
By relentlessly focusing on high-level ROI and proving flexible supply chain resilience. A standout example from our deep dive is the Lockheed Martin Javelin missile supply chain. They are currently managing over 100 suppliers and 25 subcontractors using AI-driven forecasting tools.
But managing 100 suppliers with an algorithm sounds great on paper. How does an executive actually trust a machine's forecast over their lead logistician?
Because the machine can process variables, a human simply cannot scale. The AI models are analyzing predictive lead times, global weather patterns, raw material shortages, and shipping delays simultaneously across all 100 suppliers.
Oh, wow.
Right, to proactively spot a bottleneck before it stops the assembly line. Executives who leverage AI to create that kind of resilient, predictive supply network prove the tangible financial value of the technology. And that proven success is what they use to justify the agile funding required to sustain it.
That makes perfect sense. Once you show the boardroom that an algorithm just saved $1 million in supply chain delays, the funding opens up.
Exactly.
Okay, so we've covered the DoD environment, from the mechanics on the shop floor to the analysts, the supervisors, and the command suite. Now it's time to shift gears completely and look over the fence at the commercial sector for our industry radar.
As a reminder, the tools in this segment are for your home lab or industry awareness only. They are not currently authorized for CUI or depot networks. Controlled unclassified information must stay within authorized platforms like we discussed earlier.
Important distinction, thank you. So, looking at the civilian world, what's flashing on the radar for 2026? A massive AI price war. We're looking at commercial models like ChatGPT, Claude, and Gemini, all hovering around $20 a month for consumers.
Yeah.
At that price point, adopting a multi-model strategy using all three for different tasks costs less than a single hour of an employee's time.
And we are seeing commercial workers do exactly that. They might use ChatGPT for general reasoning and brainstorming, Claude for deep writing and parsing massive documents, and Gemini for seamless integration within the Google ecosystem.
Right.
In the commercial sector, it is no longer about finding one perfect tool. It's about chaining the best tools together.
Which leads right into the biggest commercial trend: the rise of autonomous agents. We are moving way past the early phase of AI, where it was just a novelty chatbot answering trivia questions. We're past the tech bro phase.
Very true.
These assistants are now mainstream engines for everyday productivity. Tools like AutoGPT are moving from fun home experiments to actual production workflows.
The new frontier here is API interoperability. It's about a reasoning model talking directly to an automation platform like NAN, which then triggers actions in a productivity suite.
Okay.
We're seeing commercial AI move toward automated maintenance scheduling and autonomous inventory management without a human ever typing a prompt. The AI identifies a low stock level, drafts the purchase order, and emails the vendor completely autonomously.
It's just wild to think about how fast autonomous action has become just a standard part of doing business on the outside.
It is. And it raises profound questions to the future of global logistics. If autonomous AI agents are beginning to manage commercial supply chains and talk to one another, what happens to the human decision maker when two AI agents fundamentally disagree on a logistical solution?
Wow. That is exactly the kind of scenario our executive teams need to be wargaming today. As these civilian tools mature, they will inevitably shape the expectations for our defense networks tomorrow. Because ultimately, the barrier to the future fight isn't the technology anymore. It's our willingness to adopt it, learn it, and govern it. Thanks for joining us. Whether you're turning wrenches in the hangars or crunching numbers for the command team, you are the engine that keeps Army aviation ready. Stay safe, stay innovative, and we'll see you on the next Depot AI Brief.